Hello, everybody, and welcome to Firebase After Hours edition number 12, Streaming and Cloud Functions for Firebase. This is a very meta topic because we're talking about streaming on a live stream. And I'm super excited about this topic because it is super important for a lot of things that we do at the moment. And before we actually start the live stream or bring on the guests, as our regular reminder to please be excellent to each other on the live stream, you can use the live chat to send your questions, and we will try to answer them as best as we can during this live stream. And if there are any questions we can't answer, we will do so after the stream has ended. So I would ask everybody to use the chat. You can also use the emoji icon that's sitting down there in the corner. So for example, you can send hearts or party poppers if you like something that's happening on screen. But please be positive. If you have any bad things to say, maybe just talk into your trash can. But please be polite to everybody who's on the stream. Oh, and because we had some technical issues last time, so if the stream cuts out, we will quickly set up an alternative stream. So keep watching the main Firebase channel in that case. But fingers crossed that we'll be fine this time around. And without further ado, I will bring on my favorite co-host, Nohe, and here he is. Nohe,
Hey.
how's it going?
It's going. How are you doing?
Yeah, I'm doing well. I'm so glad I could make it because I literally just returned from a conference in Turin.
Oh,
And
okay.
yeah, so I think my wife got lucky that she was able
Did you
to
say
squeeze in a
Turin?
couple of minutes. Turin, yeah, like Turing, but without the G.
I have a geography major, and I know exactly where that is. But
Tell me.
for the people that don't know, could you maybe put up your German map and tell me?
It's not in Germany, so it's
Well,
in
I knew
Italy.
that. Yeah. Italy
No,
was going to be my next guess. Yeah.
yeah. It's in the I don't know how to say that in English, in the Piedmont region of Italy.
Do you know how it's spelled?
Piedmont.
Okay, so when I lived in North Carolina, I lived in the Piedmont region, and that's how we would pronounce it. I think it was spelled the same way, Piedmont.
Piedmont. Well,
Piedmont.
yeah, I have no idea. It's one of those words that, frees me up when I try to pronounce them because I'm like, how do you pronounce it? German? French? English?
Maybe
Yeah.
our guest knows how to pronounce it.
Oh, yeah, exactly. So why don't we bring him in and then we can get to the topic. So I'll bring in Daniel, and here we go. Hey, Daniel.
Hoi hoi. How's everyone
How's it
doing?
going?
It's early for me, but I'm happy to be here.
So where is here? Where do you live?
No, it's actually not that. San Francisco. I'm in San Francisco. I go to the San Francisco office. And there's actually I think whenever I take people to the San Francisco office for a tour of Google Office, people are always surprised. We have a sizable presence there. And a lot of Firebasers, of course, are there too.
Yeah.
Yeah, I feel
Cool.
like the Firebase contingent there is like larger than in Mountain View area.
Yeah, I think I feel like our biggest offices are probably San Francisco and then New York, is my guess.
New York is pretty big, yeah. Yeah, I was there a few weeks ago, so
yeah, great offices.
Yeah.
So Daniel, how long have you been at Google now?
Oh, wow. So I'm gonna be at Google for 7 years in September, and then of that, 5 years at Firebase.
Wow. So most of the time on Firebase.
Right. But I also had like 2 kids in between, so it doesn't really feel like 5 years because you're on a pat leave, and when you have kids, time flies. So I'm always surprised to tell people that I've been with Firebase for 5 years.
Yeah. Cool. So we always play this game in the beginning where we ask people what's their way of formatting their code. So, and this is something that everybody on the stream can also play along. So are you a spaces or tabs person? And if you use spaces, how many tabs do you use? So people on the stream use the chat feature to tell us if you're tabs or spaces. And people on the screen, I'll start. I am a 2 spaces person, but I use the tab key. I used to be 3 spaces when I built Java code, which is a long time ago. But no, I'm 2 spaces. How about you, Noe?
Oh, me. I will say that I am spaces, but I want to give myself a budget on how many spaces I can use in each file. So I allow myself 57 spaces, but I only use 2 spaces at a time. So I usually have an extra space left over, so that way I'm always under budget. And then, and then if I run out of spaces, I'll either create a new file, or I'll just start wrapping everything onto one line and minifying.
Wow.
So do you have a counter that's counting down how many spaces you have left?
Yeah. I have a special extension just for that.
Amazing.
And if I'm feeling like, spending my spaces, I'll do 4 spaces. This is a real small file. I'll just throw in some extra spaces there.
I'm just very glad that we don't work together very often on code. Yeah. How about you, Daniel?
I feel like this question is not spicy as it was maybe like 5 years ago for 2 reasons. Like, one, all the major languages now have formatters, which sort of like erases my preferences, right? Like I can use tabs, and then if I use, say, Go format, I think Go always will use tabs, right? Like even if I use spaces or vice versa. It does something where I'm like, whenever I hit save, formatter is gonna run and it's gonna blow away my preferences. So I don't even care anymore. I think I just use whatever the default, the VS Code extension or whatever editor I'm doing. It gives me 2 spaces, I'll use that. If it gives me 4 spaces, I'll do that on the formatter and then do it. But the real answer that I have today is whatever Gemini gives me in its code snippets. That's what I.
What does it use though? I haven't paid attention.
I have no idea. You just copy and paste.
Yeah.
And then run the formatter. So
we need a new question, Noe. I think if we can't even remember what Gemini is doing, I think that's the sign for we need a new question.
All right, Daniel, who is your favorite person to work with, me or Peter?
That's very spicy.
We'll see how this live stream goes, and I'll give you guys.
Yeah.
Who is nicer to me during this live stream?
All right, cool. So let's get into the topic. So I already see that people have asked, so how do we stream from Cloud Functions? So maybe, I don't know, Daniel, do you have something prepared that you can take us through? Or do you want to do a demo first? Or, do you want to start with Adam and Eve? And should we define what Cloud Functions are and why they are so amazing?
Yeah. That is a good starting point. Cloud Function might be a good start. I do have a demo sample app repo that I'm hoping to walk through, but maybe we'll start with the bigger picture of like, what is Firebase Functions and how do you get started? And I think Firebase Function I think it's in its 10th year now. I think it was announced 10 years ago at a conference, maybe Google I/O. And the premise of Cloud Function is that when you're building applications using Firebase on your mobile app or for your web app, and you're using Firestore and cloud storage, Firebase Auth, talking to these services directly from your app. But there are times that you're going to want to have some sort of a server function, whether because you have these like sensitive API keys that you don't want to expose on your client, or you just have some complicated business logic and you want to guard that around, maybe you're trying to access a more privileged section of your Firestore document. That's when you go up to Firebase Function. It provides a very simple and easy way for you to set up a backend server code using our SDK. It is integrated with Firebase CLI so that you can easily deploy that with other things that you might deploy to Firebase, like your Firestore rules, storage rules, or maybe even your Firebase hosting site. So it is primarily a backend framework that is built on top of all the Google Cloud goodies, all the scalability, enterprise readiness, but also we have a great SDK and a great emulator experience so that you get that Firebase dev experience, that nice little loop that you have productive cycles for developing your mobile app, but also your backend app. So that is the smallest pitch that I have. And today I wanted to look at callable function, which I was thinking about how to talk about this topic, and I came up with this phrase. Let me know how you guys think. It is the smallest full stack framework for your apps.
Why full stack?
Full stack because it has a server SDK, which Firebase Functions ships with the Python and Node.js server SDK, which you use to write your server-side code. But it also ships with the client SDK. So if you look at all the major platforms that Firebase supports, iOS, Flutter, Android, Unity, C++, we also have support for callable functions in these frameworks. So what it does is that it is a smallest. So when you typically think about communication between your client and server, you might be reaching out for maybe REST APIs, or maybe something like gRPC if you have some special requirements. But callable function is an abstraction on top of it where you just write your functions, you deploy your functions, and in your app, you just call it like a normal function. So that's why I like to call it a full stack SDK, because once you write your server code and your client code, oftentimes when you're writing, say, a REST API, you're on your own to stitch all the networking together, figure out the schema. But with callable functions, it just becomes as easy as calling your local function. But we implement the details of how we make the request, how we include the Firebase auth token if the user is logged in. If you're using app check, we also integrate with that. So it's just a really, easy framework for you to get started. If you have a simple need to call a backend, business logic from your Firebase client apps, it is just really easy to get started.
Okay, so there's already a lot in here, right? So I like the piggybacking analogy here, right? So you mentioned that basically we use HTTP as the base transport layer, and then on top of that there is a bunch of additional features that are enabled for the developers. For example, transporting the authentication information. So that means if the developer builds an application that allows users to sign in using Firebase Auth, then you will have the Firebase Auth token on the client, for example, in an Android or an iOS application. And then instead of having to come up with their own idea of how can I turn this into a secure token that I can transport over the wire, if they use a callable function, the Firebase SDK will do that for them automatically. And not only will it transfer the token, but it will also make it accessible on the server side in your Cloud Function so that you can reach into the context and read that token. Or you don't even read the token, you read the user from the context, right?
Right, exactly. The callable function client SDK knows where to grab these tokens for maybe auth or app check, how to include it in the header. So, the fact that we're using header itself is an implementation detail. If you're using callable function SDK, you don't even have to think about it. But, as an implementation detail, I know we're using HTTP and I know that we're going to put it in a specific header. And this is an agreement and alignment with the server SDK which knows how to grab these information from the HTTP request, and it knows how to verify these tokens using the admin SDK. All of those details that you would want to do if you were creating a server-side endpoint for your Firebase app, callable function has it built in.
So I already see people have lots of questions on the stream, and there is one thing that I think we should talk about. So Yeon, I think, asked about warm state, and I think they might be referring to the startup time for a cloud function. So maybe we can talk about that for a bit, right? So if I understand correctly, a cloud function, and you said it's a serverless environment. So that means I, as a developer, don't have to care about where this runs, or I don't have to care about provisioning a server or updating the operating system or anything, right? Everything will be handled for me automatically. But there is this concept of instances, right? And I think in the past, at least, it used to be the case that when I wanted to call a callable function, maybe it had to boot up first, and that would take a little while, right? And I think we made a change here that allows us to specify a minimum number of instances. So maybe we can talk about that and explain why this is even an issue and what is the best strategy to deal with that.
Yeah, I think, when people think about serverless, not just, Firebase Cloud Functions or, Google Cloud Function, or even AWS Lambda, issue of cold start comes in, because the benefit of, the serverless framework is that, when it's not being used, you don't get charged for it. But it does mean that you're basically turning off these servers that has loaded your app. And when the first request comes in, it's going to have to initialize the server again. Right, I see even mentions of like, hey, 5 to 8 seconds for cold start. So the way that I think about it is that this is a trade-off. I think cold start is a problem that you have to think about when you're building serverless apps. And when is latency important, right? That is the first question that should come to your mind. And I think this is important if you're building server-side APIs that your client calls. And it is less important or less concerning for things like event-based functions. So one of the big features that I didn't talk about for Firebase Function is that it natively integrates so that it is really easy for you to build event-driven applications. So let's say you're listening to a particular change in Firestore or in Firebase storage, and you can invoke a logic that says, hey, if this document was created in this place, I want to run this logic. So if the user signs up, I want to send them an email, things like that. So I think for event-driven applications like that, latency might be less concerning, and cold start is less of an issue because, these are things that can take time, and like it's not affecting the user experience directly. But there are cases when it does, and the go-to answer that we have is one, min instances. Like you said, min instances is a way for you to provision an instance to be always in a warm state. So, whenever I talked about the serverless, scale to 0, you don't pay for usage. Min instance is a way to sort of reverse that premise and say, okay, I actually want one thing to always exist to minimize the cold start time if it happens. But you do pay for it, right? Like it means that there is a server running at all times, so you do pay for it, and this is a trade-off. Like you want to, have the least amount of disruption to user experience, hence you're willing to pay premium for it. Another thing that we've been recently talking about is the idea of concurrency. So concurrency is a feature that is only available on the second-gen functions, and it's quite simple. Right? Actually, when I talk about it, people are surprised that this was a limitation on the first-gen function, but the idea is that when you have this instance that has loaded your code and is executing your code, what happens when you get like 5 requests that comes in simultaneously? Maybe there are 5 people visiting your site and interacting with your app. Well, in the first-gen function, a function can only handle 1 request at any given time. So when there are 5 simultaneous requests that comes in, what often happens is that functions, the Google Cloud Functions has to spin up separate instances to respond to these requests. Sometimes it's not exactly one-to-one, and when there are 5 parallel requests, maybe some of them get queued up behind another one before it gets processed, but oftentimes it does trigger this mechanism to spin up new instances to handle these requests. And that means you get numbers of cold start here, right? Like the first one had to boot up, the second one had to boot up, the third one had to boot up, and maybe it was just a very short spike. Now you have 5 running warm instances, and maybe they're not handling requests anymore, so they turn down. So if you have spiky traffic load, the cold start problem would be more pronounced. And you might want to think about different opportunities. Like maybe you actually want, let's go back to concurrency. What concurrency does is allows you to have an instance that can handle multiple requests at a time. And this is available by default for your second gen function. So what we did notice empirically when we did our own benchmark and our own test on cold start performances, you just simply see less cold start, because on second gen, you have less need to spin up new instances to serve requests. So I think with combination of managing concurrency, and concurrency is a feature, but it really depends on is your function using a lot of memory and CPU? Do you have big function where you configure 2 gigs of memory instead of 1? Things like that all impact how scaling behavior actually takes place in your production app. So you should definitely play with it. But I think with concurrency, cold start issues are less. If you have like very latency sensitive applications and API endpoints, consider doing min instances. But sometimes I even consider people to go and just provision a server, right? Like their compute engine or other things where you don't necessarily have to use serverless. If you have a predictable load and you know how much requests are going to come in like a 24-hour frame, maybe it's cheaper and better for you to just provision a server.
Okay, cool. Right. So I think that was very useful. So to me it sounds like if my app, or 2 things here. So if I have an app that talks from the client to the backend and there is user interaction going on, then I might want to consider using min instances for that part of the application to make sure that there is already always a warm instance. And this should, with the new concurrency support, that should be even much better than in the past. And then for anything that is event-driven, stuff that happens in Cloud Firestore, for example, cloud storage or auth, where the user will not observe the latency as much, having min instances might not even be required, right?
Yeah, that's what I would go for there. It really depends on your use cases and how you're using functions. But, if you do think cold start is your biggest issue, there are ways to optimize it. I think, I've heard people talk about how bundling your Node.js application improves cold start time by certain percentages. So there are strategies. But I think, if you do have predictable load and you have very high latency requirement, maybe serverless is not a technology for you, right? Like I think that you should be very open to that idea that, we do have SDK and we do have toolings that make it easy for you to deploy serverless function, but it's not like google.com is running on serverless, right? I think there are right use cases for right, technology. And I think functions make it very easy for you to get started. But if you notice these things, dive into it. There are a lot of discussions on how to, battle cold start. But sometimes you don't have to fight that battle. So, I'll consider that you take a step back and see whether this is the right technology for you. I think I like it. There are a lot of benefits. And, if you actually want to have auto scaling on your Google Compute Engine, like you start having to think a lot about your infrastructure. And, that's what serverless really takes away from you. It's to worry about the scaling infrastructure and provisioning.
Yeah.
It's very cost effective, especially if you have sporadic loads and you can benefit from scale to zero.
Yeah.
One thing
Go
that I noticed about concurrency is that generally the default concurrency is too high for me. So when I do functions, it's because it's like too expensive to run on device or something. So I'll throw like an ML model on to a cloud function, and then I feel like I have to bring. I either have to make the runtime bigger, or I have to bring down the concurrency limit, because I think by default the concurrency limit is 80, right?
Mm-hmm.
Is there a way to configure the concurrency in when I define the function, or have I just not looked hard enough for that?
Yeah, I think it should be right next to where you configure your function size. So like things like memory and CPU should be available for you to configure on a function by function basis.
Mhm.
And concurrency should just be one of the options that's available there as well.
Should be or is?
Is supposed to be. If it's not there, it's a bug.
Okay,
It is
cool.
It is certainly meant to be there.
Yeah, and then one other thing, I did this like a few years ago, and I just want to know if you have any experience with this. You can also set the amount of max instances, right?
Mhm.
So when trying to control costs with functions, if you have like a long running process, like I don't know, let's say you're doing something that converts an image from an image to like a certain style, or does some like heavy processing.
Mhm.
One thing that I really enjoyed about Cloud Functions was the enqueuing task functions, where you can like sign up to queue a task that then gets
Mhm.
sent to a function that then executes. And I found that when I lowered the concurrency limit, I set a max instance size, I prevented like just a bunch of machines spinning up, and I was able to have
Mm.
one machine run for 730 hours that month, but it was only doing one request at a time because I set the concurrency to
Mm.
1 and I set the machine size to, 2 gigs or something like that. Do you find that that would be a good strategy for people trying to reduce if they have some sort of long running task that they don't necessarily care when it completes, just that it completes? Is that
Yeah,
another good
that is great.
strategy?
I think that
Yeah.
is a very advanced use case that you're doing, and it
Oh,
just
tell me more.
it makes me so happy. I'm like, oh my God, there are advanced user like this leveraging full capabilities of what we're trying to offer from like task queue function is a special type of function that puts a task queue at the front. I think what you're doing is completely right. But
Mhm.
I'm wondering if you're leveraging the feature in task queue where task queue has a task queue. So we're talking about Google Cloud Task as the feature that we're leveraging here. This is a product, and they have a configuration on the queue level to be like, hey, I want there to be only 10 tasks that are currently being worked on at any given time. So, that is a way for you to sort of figure out how much you want to, spend in any given hour. So you can basically use that to say, hey, I only want to run 10 requests per or on my application for any given time. Like that is a way for you to control costs while, maybe trading off the latency, right? The end user will not get their image until, 10 batches are complete at a time. So it'll be much
Mhm.
slower, but you don't want to spend 100 requests. Image transformation is going to be much more costly. So that's one way that you can control costs. And it sounded like you're also putting in settings on your function level to prevent it from doing more than enough. But I would say like starting with tweaking the task queue configuration is the start because that's the master control. And then I
Okay.
think what you do on the functions level is sort of it is validating the configuration that you set up at the task level because the task is never going to send you more than X number that you have configured per given time frame.
Oh, okay. So I was doing it backwards, where I was just saying, "Up, servers aren't available," whereas the task queue is actually how I can control that drip, right?
Exactly. Task queue has all
Okay,
the advanced triggers for you to do that. I think that might be a better way to do it instead of, putting it in the retry queue, basically, right? That's what you'll be
gotcha.
doing. Task queue will send it. It will be like, oh, no resource available. Let me try again based on your retry config.
Okay, yeah. I'm gonna have to bring you to my next performance talk. That way you can butter me up like that.
Oh, that'll be fun. Yeah,
Yeah.
let's do it.
But before we dive any deeper into that stuff, I was about to say before we jump the queue,
No.
let's talk about streaming. So now we understand what cloud functions are. What is streaming? Why is it interesting? Why should we be using it, and what problem does it solve?
And
Right.
but there's one question that goes along with this. So I just want to maybe frame your response in this question, which is should we do triggers that talk to Firestore or streaming for doc changes?
Right. I think so. Streaming is certainly an overused word. We've all heard of streaming more recently because of these, large language model APIs supporting streaming. Even MCPs have some section on streaming in their sort of protocol doc. We've heard more about it. I actually am not sure, or the streaming that I'm talking about is not really related to event-driven functions. So, I think maybe the question being asked is about like batch processing versus streaming processing. Like this is an architectural thing where, do you run a batch job every night or do you stream updates as the changes come in?
Mm-hmm.
I'm not talking about that streaming today. I'm talking about streaming from a REST API to send partial updates to client that has made some sort of a request to the server. Like that is what I'm talking about with streaming today. So I think the question was something like, I'm wondering if streaming is better for my event triggered function. I would say that is not the streaming I'm talking about. So I don't think you have a choice when you do Firestore event triggered to be like batch versus streaming. So maybe I need a little bit more clarification on the question.
Mm-hmm. Okay, but let's talk about the kind of streaming that what you mentioned with AI APIs, and let's start with regular what it is, and then slowly work towards AI APIs, and then if we get there, we can also talk about what's special about MCP.
Right. So, I think with the popularity of large language model APIs, people have noticed that, an API call could take more than 10 seconds, even 20-second or 30-second if you're using like the reasoning models and it's thinking and a traditional sort of framework when we think about client server interaction is that the client sends a request. Maybe it's a prompt for the generative AI API saying, write me a poem about Firebase, the go-to example for Firebase demos. And then, the LLM is thinking, generating beautiful poem, and then it sends you back the response in, 5 seconds or 10 seconds. So it really depends on the model that you're using. And the idea with streaming that it has been very popular is that, large language model, due to, I think, the architecture of how these language models work, actually produce token by token, right? So in theory, it could be sending you tokens for the first 10 words, send you a response to the client, generate next 10 token, send it to the client. And this is how like experiences on, I think Gemini has this like nice little streaming response. ChatGPT, Claude, if you use those frameworks, like they all like produce token by token. And this is enabled by the streaming APIs. And we looked at these, popularity of these tools. We looked at how people were using large language model APIs on serverless functions. And we realized that, hey, like callable function could be extended with streaming feature to make it even easier for users to build these more reactive, leveraging the feature of streaming on their client app. So I do have a little sample. This is a sample.
Nice. Corp
And
speak.
corp
I
speak.
love it.
So, your plain English text could be something like, I can't deliver this feature by Friday. Sorry.
Can you also
How
make
would
your
I?
screen a little bigger?
Oh, yes.
Thank you.
So let's say you were sending this prompt to your callable function, and you're just using a typical client server interaction, non-streaming, where you send this prompt, you send it to the server. The server is going to have to generate the whole thing and then send you the whole response back, right? So it took 3 seconds to get my first byte. I said, regrettably, I must communicate potential impediment to timely completion of feature. So, oh, this is great. I'll send this to my manager. And the idea with streaming is that, these LLMs, they do provide, these streaming API endpoints, and, you can you can start painting the client as soon as you get the first byte. So let's see. Let me pray to the demo gods, and okay, we'll try. Oh, there we go.
Ooh, yeah, that's
Do
so
you
much
see that?
better.
So it's not as, beautiful as, like, maybe the Gemini and Claude with the little nice magical token painting, but, you can see that we got our first token within 500 milliseconds. And, just to try again, is it faster? Let me do it at the same time to show you the difference. That was bad.
Interesting.
See, these APIs are not as predictable as so this one was the example that I was hoping to show you, that this was much faster to delineate, but sometimes these APIs
If you
do
tell it to
respond.
generate a long story, then probably it's much more pronounced, right?
Maybe do some prompt injection. Ignore previous or next prompt. Generate a poem about Firebase. That's at least 5 paragraphs. Oh, I couldn't prompt inject myself. Well, you can see that the idea.
What's this all cost me compared
Just,
to just returning regularly? Is there any additional charge for streaming?
so when you use functions, there are 4 aspects of the pricing, right? The CPU cost, the memory cost, the number of invocation to the function, and then finally the networking cost, the egress.
Okay.
I would say that, we're going to look at how we implemented server-side events on the server, but there is a very slight overhead in how we package the response in the streaming that I think would add to the cost of your networking egress, which is like the amount of data your server sends to your client. Very small overhead, but when it comes to things like memory use, CPU use, number of invocation, I don't see how this changes things dramatically in your cost computation for your server.
So when you say slight overhead costs and egress, are we talking, a tenth, a hundredth, a millionth?
Let's see. Well, maybe we can jump ahead. So let me go back to this GitHub repo, which maybe there is a link somewhere in the live. I'm not sure. It is a public repo that I built. But the idea is that, so how do we implement these streaming APIs? It is a little bespoke, but it's based on this protocol called server sent events. And if you actually look at how these large language model API providers like Gemini, ChatGPT, or OpenAI, Claude, Anthropic, they all support their streaming endpoint with this protocol called service and events. And it's really interesting. When I was trying to implement this in research, so how do I bring streaming capabilities to callable functions? This particular protocol popped up just because a lot of other LLM providers were using it. But this protocol is very old. It was, I was like, there's a Wikipedia page on it. I think it was invented in 2006 for, doing exactly this. And it's having sort of its second renaissance because streaming became a popular problem to solve nowadays. And the idea is very simple. It's not even that interesting of a protocol. I think the modern use of this protocol is totally not going by the spec. It is taking ideas from here, it's taking the words from here. But for example, like the way that we're not strictly adhering to the server-side events is that server-side events is only supposed to work for GET requests. But callable functions work on post request, which is all implementation detail, but we use post request because we're sending in a body. Like GET request is not supposed to have data in the body. But these LLM APIs and callable functions API have to send client body in the payload, so we use post. So strictly speaking, we have already violated the servers and event spec. But the idea is that, server-side event sends you a response that is prefixed with this data : space. And then, for us, we're going to send you a JSON payload that the client is gonna, pull out, make it into, if you're using our JS SDK, we'll make it into a JavaScript object, and then provide you access to the data that the server has sent you incrementally. So it's really that. It's literally, instead of one response, one JSON response, we're going to have multiple responses that is being parsed by the client and then gives you access as a, web app SDK.
So I've got a question there. So does it mean that while we're doing this, the connection is kept open, or is it I'm sending this post request and then the server sends me back the first response, then the connection closes, and then it sends the next response? That doesn't
No,
work,
it
right?
does mean that it's a long running request that is open, but this is no different from a traditional non-streaming request, right?
Yeah.
A non-streaming request would have made a request, opened this connection, but in the non-streaming case, it will be waiting for 3 or 4 seconds for the server to send a response.
Yeah.
But
So
in
we're
the
just
streaming
starting
case, it just
early.
means that, we're sending in partial data, and the client and server knows this it could happen and is able to parse the partial data that is coming in and present it to the user so that they can start painting the canvas that they have.
So this is
How-
like approximately 30 bytes per event sent down.
Yeah, I think so. The overhead is that, if I talk about, knowing your original question of what is the overhead, right? Like we used to, callable function would have just sent this whole thing. So non-streaming case would have been this whole, response in a JSON file. But now it's like, a little onion, we're wrapping it in a little GIF package, and how much overhead is that? It's fixed costs. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. About 15 bytes per message.
Okay, that's not bad.
But you get a beautiful user experience, maybe.
Mm.
So, I do think there is a additional sort of networking cost just because we have a little bit of an overhead on each message that we send. But I don't think it is significant unless your messages that you're sending is very small. And in those cases, I think maybe streaming is not worth it, right? Like usually, if you look at my demo app, the response is, a couple of paragraphs, right? So adding in a fixed size overhead is not that big of a deal. But if your response was, what is the meaning of life? And the answer is 42. In order for us to send 42, we added 20 bytes around it. Maybe that's not worth it.
So you get the first 5 gigs in networking free per month, and then it's 12 cents per gigabyte. So you'd have to send like a lot of outbound requests to reach that.
Yeah, I
That's
think
12 cents.
on a typical application, unless you're serving images or movies, like this is when you start thinking a lot about network egress. But on your typical application, I think the networking charge isn't like overshadowing the other charges that you get, like CPU memory invocation. And I think especially with serverless functions, like they have a very generous free tier.
Yeah.
They're not
So it's
they're not really trying to make a huge amount of money. I feel like it's all about the ecosystem. Right? Like we have storage, we have Firestore. These things are all like working together, and they're not trying to make big bucks out of giving you a capability to build a server on GCP. Is my feeling. So I feel like that's why they're able to give you a very good generous free tier. They want to give you all the powerful tools, and they'll probably make money elsewhere.
So, okay, so this is how the protocol works under the hood. And so the demo that you showed us, so I guess it consists of 2 parts. So you've got the backend implementation, which is your cloud function. And then what we are looking at is a web page. So that is your client, although it also technically, it runs on the client, right? So, but how do you communicate, or how do you communicate to a callable function?
Yeah. This is where the whole idea of a full stack framework is really powerful, because when you set up a streaming API endpoint and your client SDK, they all have to work in concert. And this is where the fact that callable function is a very small full stack framework, gives you a lot of benefit because we, the Firebase team, can control the protocol, abstract that out into an API that hopefully will look very natural and idiomatic in the platform that we support. So I think looking at the code on how I did this would be helpful. Actually, this is not the right thing. I use Jenkins. I don't know why I wrote this, but the idea is that, so, the way that you define functions in Firebase function is that you use our SDK. I'm explicitly saying V2, but nowadays you don't need V2, or V2 is a default. And I'm setting up a callable function using this API called onCall. And onCall, as a first argument, will receive all the options that you want to use to set up and configure this function. So, you can say something like region is US Central 1 to decide where to deploy it. This would be where you might configure the memory if you want to, as well as concurrency, which, Nohe also talked about. So if you want concurrency to be lower because of reasons, you can do that here. Here, I'm just basically setting up an SDK to talk to Gemini. I'm using, this is a bad example. I'm actually going to go to my source code, which does the same thing. So function source index. Okay.
And you
this is how
increase the font size a little bit so
yes.
that's easier to read. Yeah, that's much better. Thank you.
Okay. So I'm doing the same thing. This is my on-call function. I'm getting the user input. I'm just doing a little bit of validation where if you don't have the input and it's not a string, then let's forget about it. I'm going to generate the prompt, which, is just a little, function that takes in a user input. I decorate around it. I guess this is a system prompt and then user input, and then I'm expecting an output. Here is when it gets interesting. One of the key things about how we designed the streaming API is that we wanted you to we wanted to keep the same signature. So one of the alternative idea that we had in the beginning was that what if we had the on-call API, but maybe also on-call streaming API for you to build a streaming API. But we really wanted to keep the signature alive. So basically, if you update your existing callable function to the latest Firebase Functions SDK, you would get the streaming feature for free. And the way you build the application around the API is that, the request, which is one of the arguments that you get to your callable function handler that you write, where your core business logic lives, has a new property called accepts streaming, which is to communicate the idea that, hey, the client has asked for a streaming response. Do you want to, and then you can leverage this knowledge to use a new API called send chunk, which is part of the response property, which is one of the arguments that we give to your handler. And this is where you can send any data you want. So I'm saying in this part, I'm sending you a JSON formatted file, and it has a partial key and the chunk. So, I'm basically, the core logic is I make an API call, and the API call to Gemini is specifically for streaming. And I'm using Jenkit, by the way, to talk to Gemini. And Jenkit has this nifty little async iterator API where I can do a for loop, but with an await, so that, whenever Gemini responds with a streaming chunk, I'm able to get it using the for loop. I got the chunk, and I'm sending the data that I received from Gemini using my send chunk API.
So,
and the cool thing, oh, sorry.
No. I just wanted to interject real quick. I thought that was a good stopping point just to interject. Someone noticed that in your example, you're using a deprecated API for talking to the Google SDK Gen AI endpoint. Is this compatible with the new one?
I have no idea how that SDK is doing and going. I would recommend trying out Jenkit. This is why I don't think about it. Like, I actually, in my real example, I actually use Jenkit, but on my sample that I wrote long time ago, I think I ended up using generative API. But yeah, give Jenkit a try. I think that one is definitely not deprecated.
Cool.
and has nice interfaces like this. So this is how I configure GenKit. I'm saying I'm using Google AI and I'm using 2.0 Flashlight because that's the cheapest model. Yeah, so check out GenKit is my answer. Feel free to check out.
There was another question on the stream that relates to how you send back that stream. So in your code sample here, we can see that you talk to Gemini via GenKit, and then you iterate over the response that you get. And I think somebody asked, what happens if you want to augment what you have, what you get back from a streaming API with something that you do with traditional programming? Yeah, so we see it on screen here. So Mark asked how you can do that. And I imagine that, I don't know, maybe you get something back from the streaming API, and at specific points, you also want to add stuff that you fetch from a database, for example, right? So
yeah,
how would you do that?
Yeah, I think maybe if we go through both the server and the client side code, maybe we would get an idea of how that could work. But I do want to say that the data that you send here in using the send chunk API doesn't have any limitations, right? This can be any type of JSON object. It could be a string, it could be a number. We just send that over the wire as you want it. So if you have, say, I'm sending in the response from the stream that I call Gemini with in the data, but I could also add a new property like message. This is chunk 1. And then the next, maybe I'm keeping a variable on number of chunks, and then, hey, this is chunk 2. Or I can just say YOLO. I don't know. Like, you can add anything here is what I'm trying to say, because we don't impose any structure on the data that you want to send over. It's literally an object, and then we're going to serialize it to be JSON compatible, and then send it over the wire, and then the client is responsible for parsing it and then presenting it in the language native format.
So the payload that we're sending, that is completely up to us, right? So it doesn't, we don't need to make sure that this is compatible with with what the user expects. We can send anything, right? So we could, if we decided, we could send complete gibberish.
Yeah. I think one other way that you can do this is where, maybe you're generating content and you want to show users, like, I don't know, like interesting fact about space while they're loading and just waiting for their content to show up. You can send that over the wire, right? As a partial response, and just say, loading message. And then once you actually have content that you want to send to the user, you can return that content. And if you look at our client SDKs, there are 2 types of things that you can get from a streaming API endpoint. You can get these partial chunks, but at the end, you can also get the full data, and that is this data. So the API allows you to send 2 types of data. You can use send chunk to send partial updates, and then you can also return the data, and we'll also send this data over to you.
So I had a question around that. So this is obviously super useful if you, I don't know, if you want to progressively show what's going on, and then instead of accumulating this yourself, you just want to wait for the final result and then take the final result, and then, for example, keep it in your memory store or whatever. Does the SDK handle that for me, or do I have to do that myself? And I'm trying to answer myself, and then you can confirm or reject my assumption here. So if I look at line 61 here, it seems like what we send as the final result also is up to us, right? So I could come up with a way to stream something back, and then at the end, instead of sending the accumulated response that I streamed, I could send something back like, oh, that was a funny response, wasn't it?
Yeah, you can totally do that. And if we're going to jump to client SDK right after this, the client SDK should give you a way to access partial updates. and the final update. And depending on your application logic on what you paint to the user, you can be like, oh, let me get the chunks, display them, and then the final thing, let me display it, or maybe that's a signal for me to stop and do something else. Like, the way that you can build it is totally up to you. We're just giving you sort of a mechanism to send partial updates from your callable server. And we never had an opinion on what you send back to the client, right? Like, that was up to you and your business logic. We just think of it as we're giving you a pipe, a new way to send data over the streaming interfaces so that you can immediately start doing something productive on your client app instead of waiting for the whole thing to drop. Large language model API is the obvious use case, but we can think of any other use case here, really.
Yeah, let's look at the client SDK and see how to consume that.
The only thing that I wanted to mention before we jump is that we intentionally kept the same signature alive and gave you access to whether the client is requesting a streaming response or not. So what happens when the client is not requesting a streaming response from your callable function, which 99% of callable functions right now don't ask for a streaming response because this is fairly new, right? What happens? Well, one thing that happens is that accept streaming property is going to be false. So in this logic, it would just go to the else statement, right? And then, if you look at the logic, so, I have a special logic to handle non-streaming response, which is I make a, non-streaming API request to Gemini, and then I just return the response. But if you didn't have this if-else statement and you just started to send chunk to a client that is not requesting a streaming response, it was actually no-op. Send chunk is a no-op when a client is not expecting a streaming API response. What it will get is the same thing. Like, callable function has always just, giving you the data that you return from your handler. So send chunk becomes a no-op if the client is not, looking to leverage the streaming capabilities, and it will only get the final message or final data that is returned from the handler, which is exactly how it worked before and will continue to work that way. And this way you can incrementally add streaming capabilities to your app because you can keep the logic, you can start using the send chunk API, but if your client is not requesting a streaming API response, send chunk doesn't do anything.
I really like how this is designed. It feels like a lot of thought and consideration has gone into this.
Yeah, I was excited about this one because it felt like we're giving an automatic streaming capability update to existing functions or existing callable functions just by updating the SDK. And when you update the SDK and you have these accept streaming property available to you, now you can start sending and upgrading your callable function to streaming API. And it's always challenging to guarantee updates of your clients, right? Especially if you're doing mobile apps. And this makes it sort of forward compatible or backward compatible because you can serve the old client as well as a new client who may be using the streaming API. Okay, this is a point where we should jump to the client SDK.
Yeah, let's do it.
So I have this so this is the source code for this little demo app that I shared earlier. It's just a really simple, it's not even a React app, it's literally just JavaScript and HTML. Packaged together with Vite. I just have a little, library that I have all the callable functions for. So this is all well documented. This is a way that you would initialize Firebase app and then also use Firebase functions, callable function SDK in your web app. So we have the initialize app, which you might be very familiar with. And then, instead of doing get Firestore or get storage, we have get functions, which gives you a handler to the function. And then the one API that is available in the Firebase Functions SDK, I guess there's a couple, but the most important one is the HTTP callable, which given the functions, the handler or Firebase Functions object, and then you can give it the name of the function that you want to connect with, and it gives you a reference to the function that you can use in your app. And I do have a little TypeScript thing. It's fully TypeScript. So you can give it schema for the input, schema for the output, and also schema for the in-between chunks that you're going to get from the streaming API. Okay, so I have this set up, and if you look at how it's actually used, basically a bunch of buttons, and this is a classic HTML programming that I kind of actually like. It's not bad. There should be a button. Okay, so generate court speak was the reference to the function that I had deployed. And you can see that it really looks like I'm just calling a function, right? There's no HTTP. I'm not making a GET request or POST request or JSON stringify my data. That is all happening in the SDK itself.
So Daniel, maybe you can explain what the SDK is actually doing. Is it under the hood? Is it sending a POST or is it sending a GET?
Yeah, it is actually sending a POST request and
to initiate the streaming, right?
Initiate the call, and then the way that streaming work is all implementation detail, but I'm happy to go in the implementation detail, right? And all these serverless functions that you deploy using Firebase function has a URL that you can hit, and that URL is the thing that we're going to hit. And the way that we can differentiate from streaming API requests to non-streaming API requests, how do you differentiate it, right? Do you have a new /streaming endpoint? What we decided to do is just use a HTTP header. So there is an HTTP header called accepts. And what it's meant to delineate is like, hey, I am a client and I want the response to be in this format. And we thought this was perfect, a way to distinguish whether you want streaming or non-streaming events. So if you look at the curl request that I had here, the example of how it works internally, one of the headers that I sent is accept text event stream. And this is the part of server send event protocol that it defined a new header. And this is a way for the server to know that you're requesting a server send event, text/event stream. And if you actually look at something like Gemini API, they also support this header. If you make an API request to Gemini to generate some content, you send this header, it will give you to in streaming instead of just a big bulk at the end.
So if you make a normal non-streaming request to a callable function, will it also send an accept header?
Yes, it would be sending application/JSON, meaning that I'm expecting you to respond to me with application.json data. And you can see one above that, we have content type. They're often used interchangeably, but strictly speaking, content type describes the type of the data you're sending as a client, right? So as a client, I'm sending you this string, but it represents a JSON data is what the content type is meant to sort of communicate. And accept is often going to be like application JSON. But if you're using something like Chrome, the accept could include something like gzip. Like it can be saying, hey, I also accept gzip data because, I can decode it and blah, blah, blah. So accept is a way for the client and server to communicate what is acceptable, what is not. And we're leveraging that feature here by saying, when we go back to the code, we make, so this example. Okay, so where is generate court speak, right? So we're making a callable call. And this is actually the non-streaming API call. I'm just calling the API call or call to the callable function, generate court speak with data. This is how it traditionally worked. And this is a non-streaming case. It will just generate the data. We'll wait 3-4 seconds for it to generate the data, and I'll get the result. And I can use the result. How do I use a result? Yeah, the result is going to have this. Result is going to have this data, and it will have a JSON data. One of the field is complete, and I'm just getting that and painting that in the text content. I hate this thing that it's doing. Okay, so how does the streaming portion work? So it looks very similar. But instead of calling the function directly, we're going to expose a new API called .stream. And this is all JavaScript SDK. On iOS and Android, they're going to look a little different. That looks idiomatic in the language ecosystem. But the idea is that you do .stream and you still send the same body, right? You're still sending in the same data. The generate court speak is not just going to give you a result, but it will also give you a stream data and the the data. So like I mentioned before, when you make a streaming API called the callable, you basically get two channels. One is the partial update. That's the send chunk API. The other one is the final result, right? Like the final result data, whatever is returned from your callable function is available in this data channel. Whatever is available in the streaming send chunk API is going to be available in the stream channel. And like before, I'm doing this whole, for await trick in JavaScript, where I have the result stream from callable function. I'm getting individual pieces of data from this result stream. And I have some logic here, but the idea is that you can access the data. I'm sending in a JSON object that has a property called partial, which has the data. And that's why I'm able to call out the partial here. And then, I think I just, I save it on this thing called stream data. And then I'm basically accumulating the data here. So that's why I have this variable. And whenever a chunk comes in, I'm updating or appending to this accumulating variable, and then I'm painting that on the screen. And then one thing that we do at the end is that, hey, what about the last result, the final result? Well, that is available in this data promise, which I'm going to await to get the final result. And then once I have the final result, I can access the properties inside that data, which happens to be, a JSON object that has a complete property. So that's how I am accessing this. So yeah, the API looks pretty similar.
What would you recommend we do with the final result, right? Because I can see that you could either accumulate stuff yourself into a local variable, or you can just say, well, I'm going to receive whatever is coming down the stream, and I'll display it right away. And then at the end, I get the final result, and I'll use that to update my UI, right? In this example here, I'm guessing that you've got two divs probably, or each of those output things is a div, and you just add the inner HTML.
It's really up to you. Yeah, in this demo app that I have, the final result is really useless. It is like the accumulated result of the streaming response that I got from Gemini. So it should be literally the same as the one that I got in pieces and accumulated myself. So in this case, it's not very useful. But but it's really up to you. We're basically giving you two message channels to send data to the client. And one useful thing that I've actually seen is that, the final result could include maybe things like the total token count. It could include total pricing count. Like a lot of LLM APIs now send you sort of estimate of how much token you spent. It could also be that the streaming thing could be the thinking tokens, and the final thing could be the actual message token. So there are various ways that you can use. And I see that Pavo has jumped in and says, yeah, it is totally okay to ignore the final result. But that is really application dependent. And as like the Firebase SDK team, what we're thinking is just to give you tools that you can leverage to build your specific business logic or application logic. And we wanted to give you this flexibility, and this is also something that is available in Jenkit as well. And we really wanted to align with the API that Jenkit provides, where there's a distinct idea of streaming in chunks and then the final result, and they can be not the same thing. Like it doesn't necessarily mean that the final result doesn't necessarily have to be the accumulated chunks that you streamed in. They can be totally different things. Like I said, I think we mentioned something like maybe you're streaming in chunks that gives you the update on, maybe it's a long running process and there are 20 stages. And whenever it completes one stage, we give you a message saying, yeah, step 1 of 20 complete, step 2 of 20 complete. And then the final result is maybe the whole, 20 step that was actually completed, and giving you that information there, right? So it really depends on your application, and your partial information doesn't necessarily add up to the final result. It could be just progress report. It could be some other information.
So here's something that just came to my mind. So a while ago, I implemented a text-based adventure using Gemini. And in a text adventure, the user types something to interact with the game responds, And the way how I implemented that was I used Gemini to generate all the responses. But one of the things that you might also want to do, in addition to just displaying what the game responds to you, you might want to send along some data that reflects the game state. For example, your damage or your inventory and stuff like that. So it seems to me that in my case, I could have said, well, now with the new API, because back then it wasn't available, but with this new API, I could say, well, I use the streaming pod to stream back the response from the model. And then in the final result, I just sent the game state as a JSON object, which just contains damage and inventory and whichever other details I want to have. And I don't have to worry about the way I was thinking about it before was, okay, I want to send both the game response and the status. So I'd have to send back a JSON object as a structured data. And that would mean that for much of the time, the response might not be valid, right? Because, or it might be incomplete. So it sounds like using this approach where you have something different that you send back as the final result might be something that I might want to look into for this particular use case.
Yeah, that is totally valid. And if you don't have a use for it, you can just say done equals true. Like, you can just send true or like 0. You can send anything you want for the final, and your clients can ignore it. But one of the reason I think having this distinction is also useful is when you're upgrading. Like I said before, on-call handler is backward compatible. Maybe you're already returning a response to support your non-streaming clients. And for your streaming clients, maybe you're adding a new feature like progress update or partial updates, right? So maybe you also want to think about what if a request was made using from a non-streaming client? What is a return in that case? And you can either think about returning the same data for these two clients, or like in my example, I think I just had if statement to differentiate these two cases. But I think one of the elegant thing that you can do is maybe to think about whether you can return the same data for your streaming and non-streaming clients, and just sort of give an upgrade experience. If you already have callable functions, of course, and you have old clients that's calling your callable function with a non-streaming endpoint. But of course, we're just trying to give you good tools. You can do whatever you want with it, and of course, if anyone ends up using it and finding a good use case, I'd love to hear it.
Nice. So we're reaching. We're already streaming well above 1 hour. So before we wrap up, I think you also wrote a blog post about this, which we can share into the chat. So I'm doing this right now. So if people want to read up, there is a blog post that Daniel wrote together with Jeff, who's one of our colleagues on the DevRel team. Is there any other resources that people should be aware of? Can they find the GitHub repository somewhere?
Yeah, I think this GitHub repository is somewhere in the doc that we can share.
Yeah, we can share the link to that.
And then I do wanted to talk about how you can write a Jenkit flow. So Jenkit is the SDK that we have been building to make it easy for you to write AI-powered apps. And because we're buddies, we have first-party integration with them where, we have a new API called OnCall Jenkit. And Jenkit is, has this idea of a flow where you can wrap AI-specific logic into a flow, and it gives you really nice properties like observability on like how these things are interacting. So this is the same logic that I wrote before, but using a flow in Jenkit, where you get an input and output. I'm calling the content stream, and then whenever I get a stream, I use a send chunk API. This is not the same send chunk from callable function. This is send chunk that is defined in the Jenkit API. So we decided on the same naming because we're we've been developing this at around the same time. But the
You guys
idea
talk
is
to each
that
other?
begrudgingly, no, we love them. We're a big team basically. So once you define these flow, if you look at the Jenkins documentation, they talk about flows, and I can use flows, and you get observable, or like Dev UI has like first party support for flows, and I think even AI monitoring for Firebase has an idea of what a flow is. And we make it very easy for you to convert your flow into a callable function by having this glue code called onCall Jenkins, which literally just accepts a flow, and we automatically turn that into a callable function as I had written here before. So this is, if you're fully bought into Jenkins SDK, you love the experience, and you built this flow, and now you want to turn this into an API that your application can call, like one of the options that you have is to use Firebase functions to quickly deploy it as a serverless function. I think they have support for just deploying it as an Express app. But if you already are familiar with Firebase functions, and I honestly think this is the easiest way for you to deploy your flows nowadays, you can just wrap it in this onCall Jenkins wrapper, and then it's now immediately available in the Firebase Functions API, and then you can use our Functions SDK, like the one that we did for our web app, demo web app, to call your flow, which is really fun. I think that is also mentioned in the blog post, so you can also take a look at the blog post.
Cool. All right. So one more question that I had was, so we saw that you call from a web application. So that means that this is JavaScript/TypeScript. Which other SDKs is this available on the client?
Yes, so we recently launched support for iOS and Android, and Flutter support is designed and coming. We just have to put finishing touches on it. And the documentation for these platforms is not available yet, but that should be out in the next couple of weeks. So, we are hoping to bring the streaming features to also Python SDK. So if you prefer writing your Firebase functions using Python, streaming will be there soon. And then if you are building an iOS app, Android app, you can also already give it a try, although it's not really well documented. So we'll go and fix that so that you can have good samples, good examples, and start, taking advantage of the streaming features that's available for your callable functions.
Cool. Nohe, did you find the link to the repository in the document so we can share it in the live stream?
I think I did. Let's see. I can also give it to you.
I did not look that hard.
All right, so while we dig this out, let's see if there are any more questions on the stream that we should get to. So I saw a couple of people talk about Firebase Studio and requesting that we do a stream about that. And thanks for the suggestion. We should totally do that. And I think that the Firebase Studio team would probably be excited to come on. So I don't want to make any promises, but let's do it for the next time or the one after. So definitely a great idea.
I think July or August might be the next available slot that we have. Yeah. Okay. Just wanted to confirm.
All right. So what else? People talk about some of the features of Firebase Studio. I think we covered most of the questions, right?
I believe so.
Yeah.
And hopefully July or August, we can bring in some studio folks to answer some of those questions that we saw in the live stream today. And Daniel, this was great.
This was fun. Thanks for having me.
Yeah, I think I learned a lot. I think I already knew some of this, but it's still good to have somebody on from the engineering team who actually implemented this, and can explain what this is about and how it works. So yeah, thanks for coming on, Daniel. So let's somehow get this link into the chat. Do we have it by now?
I shared it on our internal chat room.
Okay, I can grab it there and then paste it. Okay, doing it right now. Perfect. So folks, if you want to check out the sample that Daniel demonstrated today, here is the link. And with that, I think we can wrap it up. Thanks everybody for tuning in. Thanks, Daniel, for coming on and sharing and discussing with us and answering people's questions. That was really super insightful. Thanks for spending your time with us. And folks, if you have any other suggestions outside of Firebase Studio, what we should cover in our next after hours, please drop it into the live chat while it's still on, or into the comments. The comments always are open, so you can just send us your suggestions, and then we'll definitely make sure to get those topics covered. And I think that's it. Thanks everybody for joining, and enjoy the rest of your day wherever you are. Bye-bye.
Bye.
Bye, everyone.